Hello folks, welcome to the session Developing IoT Edge. Today I'll try to explain where we are with the various activities in our IoT and Edge native working groups and see what has been going on for the previous year and how we are tying things together, trying to develop and bring IoT to the edge. But as I said, before we start talking about the future and the present, let's see and recapitulate what we have today in our community. So from the IoT perspective, we have Eclipse Hono project, which is kind of a IoT Cloud Gateway, aiming to provide a uniform access for millions of different kind of devices to the cloud, right? So it's a cloud scale and it's a multi-tenant system to easily build IoT clouds, providing a uniform way for devices to send telemetry data and IoT solution to send commands and control back to the devices. Once we dealt with the connectivity layer and we have our devices connected and being able to push messages back and forth, we need the developer framework, and that's usually in the IoT world some kind of a digital twin platform. In the Eclipse world, that's Eclipse Ditto project, which provides a digital twin and deals with the state management of the devices and providing developer APIs for IoT solution developers to be easily to get the state of the device and configure and send commands back to the devices. One final piece of the puzzle for successful IoT cloud solution is a device management component, and that's what Eclipse Hogbit is. So basically, Eclipse Hogbit provides a framework for rolling software updates to the devices, and those updates could range from the framework or from the firmware updates to the application level binaries, right? So it supports everything this kind of software needs to do. So scalable again to a proper cloud levels and supporting millions of different devices and supporting complex rollout strategies for updating large number of devices in a campaign. So far, these projects worked well in their own domain and could be easily used on their own. Of course, they all have been developed to work together properly. But in order to do that, you would need to do a manual installation of the whole stack and do all this work on your own. Over the time, the Eclipse IoT community on the cloud side standardized on the Kubernetes. So the idea was to create a new project. We call it IoT Packages to provide Helm charts for all these projects and maintain it there. But on top of that, provide different kind of packages that can be used to easily install and have off-the-shelf cloud platform for you. So as you can see in this example here, so using the Cloud to Edge bucket, you can easily with one Helm command install the whole thing. So have a properly installed Hono, Ditto, and Hogbit stack, and being able to connect your devices with your IoT solutions. So that's the state of the IoT cloud today. So right, we have devices connecting directly to the cloud and over the messaging network today. That's the MQP network connecting it to IoT solutions. where we want to go with the IoT Edge is to distribute this architecture a little bit. So, for example, we can see this, that we still keep the IoT cloud, but we also can have multiple edge locations. And what we want to do here is to be able to connect devices directly to the cloud still, but also to be able to connect to connect them to these edge locations in the same manner. So for the device, it doesn't have to make any difference. But we also want to make sure that we can distribute our IoT solution over the edge sites, so that we can have a local local data processing if needed. So before we go to see how we're going to do that, let's take another piece of the puzzle and take a look at how things look from the edge side. So one of the initiatives of the Eclipse Edge Native Working Group is Eclipse IoT ioFog project, which provides a general framework for running containerized microservices on basically any hardware, and providing a true edge computing a platform, being able to add a lot of value add on top of that, like edge hardware security and hardware abstraction layers and things like that. So if you take a little bit of a look at the ioFog architecture, you can see that it's a common pattern in this kind of system when you have one controller probably running somewhere in the cloud and multiple edge sites and edge devices. And here you can see that we have two ways of communications here. So one is a control panel, control plane, being able to control agents and get the states of the agent from the controller. And other is the data plane, which basically is the communication between different agents and between themselves and the cloud and the controller itself. So before we go into the details, talking about this communication between the edge nodes is an important topic and something we have been dealing with over the past year. So edge computing poses a unique challenge for the networking, because basically you have a lot of your services running in a private subnets and private networks, which are not addressable within each other or for the public. And in order to be able to do that, we need to provide some kind of a mechanism so that we can be able to do a couple of things. First thing is to have outbound only communication connections, meaning that nobody can dial into our edge locations for the safety reasons. But then once we have this notion of the physical connection between the edges and the cloud established, we want to have some kind of the overlay communication network where we can easily address services running in these locations, completely unaware of the network topology and without any need for VPNs or technologies like those, which keeps these solutions much simpler in reality. And for that, the Red Hat is working on the Scupper project and the technology, trying to provide exactly this. So layer 7 routing and layer 7 overlay network between the multiple clouds or multiple edge locations, and providing proxies for different kind of services to be able to easily use this network. How this look for example, in the Kubernetes space, is that you would have a multiple AMQP routers interconnected, and then the services in each of the namespace in different clusters would be proxied to this router network, and the users of these services would be completely unaware of the topology of the whole system. So basically trying to get an HTTP request from one cluster to another, that request would be basically encoded into the AMQP message sent over the router to appropriate service in appropriate cluster, and then reverse proxied back and invoked appropriate service running in that cluster. So if we get back to this picture of the ioFog, that's one of the things we already did over the past year. So as you can see, the control plane traffic between the edges and the controller is now going over the AMQP. The ioFog project implements appropriate proxy services so that their microservices can invoke those proxy services and basically being able to reach out. So microservice A can reach out to microservice B without being able to directly connect to that edge location. So as you can see, we have now all the bits and pieces we need for this. So we have a scupper to provide us with the connectivity between the sites on the AMQP layer 7 layer. We have ioFog as a edge computing platform that we can use. And the last thing we need to do in order to be able to connect devices properly to the edge is to do some work on Hono to make it more edge friendly. Eclipse Hono is a Java based project using Vertex and Spring Boot originally to implement all the microservices in its architecture, which works fine in the cloud, but we can do better for the edge. What we started to do is basically moving the stack to the Corpus, trying to provide a native images for the starters, for the protocol adapters if they need to live on the edge sites. And one of the promises of the Corpus is that it uses the GraalVM and can create native images, and with the usage of native images, the consumption of memory for those services would be dramatically reduced, and also the startup time of the applications and all of the services would be greatly improved. So these are the official Corpus data, but from the initial work we did, so last week we released Hono 1.4.0 with HTTP and MQTT adapters using the Corpus, and what we can see from those is that these figures are holding true. So we are getting down from the 200 megs of the previous memory consumption down to like 40-50 megs for the protocol adapter, and it's a big thing, and it's a big improvement if you want to use these components on the edge sites. On the other hand, we also need to do more work on the internal Hono architecture to provide a more flexible communication between the Hono internal components in order to be able to better support edge use cases. So this was the use case where we wanted to to talk about of having the IoT solution also deployed on the edge and having the proper architecture for that. But in a lot of cases, that's not necessary. In a lot of cases, we would have some kind of the gateway or the adapter on the edge running, talking with the proprietary protocol and digest the data, and only that then send some data up to the cloud. So in this case, we would only consider Hono as an IoT cloud, but we need to provide a better way for developing these protocol gateways. And that's something to have in mind and something to work towards on in the following year, providing a good protocol and a good framework and good library set for developing third-party adapters and gateways for Hono. One more initiative, which is really cool, and it's ongoing, is to rethink the overall IoT gateways architecture. So the general idea is why wouldn't we be able to use all this tech that I've been describing here today to actually implement the IoT gateways. So basically create your applications on the cloud side using Ditto and Hogbit, and provide all necessary components on the IoT gateway infrastructure to be able to communicate with those. And basically, what we would like to do is to create to treat IoT gateways as a general purpose edge nodes. And why not start trying to do that with the ioFog and with the technology we already have within the foundation. So one more missing bit for all that to be able to be done is Eclipse Hono, which is basically a language for the digital twins, and it allows us to basically model different devices in a way that we can later on create APIs from these models. But also the goal of Eclipse Hono is to create a repository of all these device models. So one course of action was to try to capture all the functionality of IoT gateways and general purpose edge nodes in terms of the Eclipse Hono models. So what I'm showing here is a couple of models. I think they're all still in the draft mode, so not publicly available, but you can get the idea here. The idea is to try to define all the things that we would like to manage and monitor on the edge side or on the IoT gateway, like network adapter configuration or operating system details and things like that, and create a Hono model for starters. But then from that Hono model, you can create a Ditto API to be able to basically get these details on the cloud side from the IoT gateways. So this is how one of those models look. It's a system resource. And you can see here that within the model, you have a couple of blocks. So basically a configuration block showing all the configuration parameters for the resource. Operations are the things that of the operations you can invoke, and basically events showing the events you can expect from this model and from this resource. So back on then you would have appropriate REST APIs to get this configuration, call these operations, and monitor these events in Ditto. So this is just a first step, and basically, you know, this is the ongoing process and call for action, basically for the community. And you know, some of the tasks that are being done at the moment and planned on is to try to so the ioFog switch, it's control plane, data plane communication to Scupper. So let's try to use Hono, because Hono is the glue between the Hogbit Ditto and the devices. And in this case, the ioFog agent is a device. So if that ioFog agent can talk Hono protocols on the control plane level, it will make things significantly easier. And then, you know, the connectivity is one side, but you need to implement the agent logic that would actually use this Porto model and the APIs derived from them, and implement the detailed applications for actually then managing these ioFog agents from the side, from the cloud side. So that's where we were, that's where we are today, and that's where we are thinking of going tomorrow. As I said, there are two working groups within Eclipse. One is the Eclipse IoT working group, and the other is Edge Native working group, trying to work closely together to provide this IoT Edge future. And please join either one of those groups, depending on what's your current interest and the future interest, or both of them, and join these communities and join the efforts we are trying to provide here. Thanks again for joining the session, and I hope you will have some interesting questions now for me. Thanks. Now, 1 month later, here I am to answer the questions about the session. There's a lot of questions being asked and answered during the session in the session chat. So go take a look at there if there's nothing would like to ask now. Yeah, I think one of the benefits of pre-recorded sessions is that I was able to answer the questions in the real time. So that's good. And thanks everybody for joining the session. I hope we'll see you, as we said in the last slide, there's two working groups. IoT working group where we do a lot of work on the individual projects, so Hono, Ditto, Hogbit, and the packages project, and then the new Edge Native working group where ioFog is, and where all this further integration between these projects are taking shape. So anybody having any interest in all these topics, you know where to find us. Thanks again, and see you online.